Hi friends, applying ideas and concepts from one field in another fields often lead to unexpected and surprising results. Today, we apply a concept called bag of words from natural language processing NLP in computer vision. Now, here we have three pieces of text. Let's call them documents, right? The first one is about the bird, and the second one, the third one. Now, let's say we want to classify these documents, or it could be sentiment analysis or anything using machine learning algorithms. Since the ML algorithms only work with numbers, not text, we want to somehow transform these three documents into a bunch of numbers. Now, one such very simple technique is called bag of words. In this technique, what we do is, first we take all our documents, we find out the vocabulary, meaning all the unique words within the corpus. So here we have, from the first document, we have about the bird. We have three words, unique words, and then from the second one, we have you, heard, and the third one, we have is and the. So these three documents have total 7 unique words, which are listed here: about, bird, heard, is, the, word, and you, right? That's the first step. And in the second step, all we do is, for each document, we count how many times each of these unique words appeared. Okay, so for the first document, about appeared once, bird appeared thrice, here, and here, so on and so forth. We do this for all the documents. Now that these three documents are transformed into a bunch of numbers, let's call them features. So we can use these 7 features in any machine learning algorithms to classify these documents. Okay. Now, if we want to make it more generic, we can have all the vocabulary in English, which is around 500,000 words. So we would have a vector of 500,000 words, but except these 7 words, all the remaining words have the counts zeros anyway. So they are not useful anyway. But irrespective of the size of the document, each document is transformed into a vector of fixed size determined by the unique vocabulary within that given corpus. Okay, so that's bag of words. It's a very simple concept. Now let's apply the same concept in computer vision, right? So now, any image is a collection of pixels, and each pixel is a combination of 3 primary colors: red, green, and blue. So just like a sentence is made up of words, images are made up of pixels, and each pixel is made up of 3 primary colors. For example, this image, it has 500 pixels along the x direction and some 375 pixels in the vertical direction. Okay, so the total number of pixels is 500 multiplied by 375. And any pixel on this image consists of 3 primary colors: red, green, and blue. And each color have an intensity between 0 to 255. So the intensity can be 256 values. So what we do is, we take a bunch of images, we go over all the pixels one by one, and for each pixel, we extract the intensity of the color for all 3 channels: red, green, and blue. Similar to how we constructed this bag of words matrix, we will construct bag of colors matrix and then see if we can use that matrix in a machine learning algorithms. Okay, that's the idea. All right, so CV2, that's for image processing, NumPy, Matplotlib for just from plotting. Now here is the main code. So what we are doing is, for each image, for a given channel, right, which can be red, green, blue, here we initialize an histogram with all values 0 to 56 values 0, and then we are going over each pixel one by one, right? So for each pixel one by one, and we are extracting the intensity of the color at that pixel, okay, for a given channel. Okay. So we extract all the intensities, and then we simply count how many times that intensity has appeared. Okay, so we are essentially taking the histogram of intensities of pixels for each channel. All right, that's the function. And then here, for a given image, here we are simply reading the image, and then so this function we just saw. So the first 2 dimensions are length and width of the image, and the third dimension, that's the channel. So 0, 1, 2 meaning red, green, and blue. Okay, so for each channel we compute the histogram, and here we are just plotting the image as well as the histograms side by side. Let's see how they look like. Okay, so here we have an example image. It's a synthetic image. You will see in a second. We read the image, we compute the histograms in all three directions, and we are plotting the histograms. Now, this is the image we just saw. Okay, so it is a 100 by 100 pixel image. So total there are 10,000 pixels. And then first, when we look at this red channel, which is this channel, this has dimension of 256, okay, indicating the intensity, each intensity. Now, this value 0, meaning this image has 0 pixels with intensity 0 of channel red, okay, because every pixel of this image has red intensity 255. So that's why you will see all these numbers 0 except the final one, which is the intensity 255, and the count is 10,000, which means this image has 10,000 pixels with intensity 255 of channel red. Okay, I hope that concept is clear. That's the crux of the whole idea. And then, since this image is made up of only of red color, for the green and blue, we don't have any intensities. So that's why you see here the number of pixels with blue intensity 0 is 100,000. Similarly, the number of pixels with intensity 0 for green channel also 10,000. All right. So here we are just plotting the histogram. As you can see, for the red color, all the pixels, all the 10,000 pixels have intensity of 256, and the green and blue, all the 10,000 pixels have intensity 0. Okay, I hope that concept is clear. That's the crux of it. All right, here we have another image consisting of only green color. So here you will see the histogram just picked around 256 value for the green channel. For the rest of two colors, it is 0. All right, same for blue. Now, when we look at white color, it is the combination of RGB with maximum intensities. So that's why here you see none of the pixels have 0 intensity. So all the 10,000 pixels have maximum 256 intensity for all three channels. Here we don't see clearly because the blue one is plotted last. So the blue overlapping with red and green, but all three colors have the highest intensity of 256 for all the 10,000 pixels. Okay. Now when we look at a black image, it's the opposite of white. So all the pixels have 0 intensity. But let's before we look into some real world images, so here we have another synthetic image, yellow. Yellow is made up of red and green. So here you will see the blue at 0 and red and green max 256 intensity for all 10,000 pixels. Okay, so when we combine a pixel of red with max intensity 255 and pixel of green with max intensity 255, then we get a yellow color. All right, so you see here yellow image, the one we just saw, and here you will see, so for the blue channel, all 10,000 pixels have 0 intensity, whereas for the red and green, all 10,000 pixels have maximum intensity of 256. Okay, so this is how the histogram look like for real world images. So here we have very thin green leaves, so that's where this peak is coming from, and the pink, a combination of all three colors, mostly coming from these areas of histogram. Here we have another image, again a combination of all three colors, as you can see. Now it's mostly red and green, but because of the scale of this histogram, where the blue has all the values 0, we don't see red and green here, but this image is mostly made up of pixels with green and red colors. All right, so here is another image just to show you how the bins look like, or the histograms look like for real world images. All right, now can we make use of such information to train a machine learning model, right? Just like how we converted sentence into vectors of numbers using bag of word concepts. So here we are taking all these images and we are converting them into vectors or numbers of fixed dimension. Okay, so the dimensions are 256 for each color, 3 colors, it's 256 multiplied by 3. All right, so what we do is, so here I have a folder with some flowers, daisy, rose, different colors of rose, not just one color, and then sunflower. So each folder has about 750 images. Let's apply the concept to train a very simple logistic regression model to see if we can differentiate those images just based on the color intensities, right? All right. Okay, so this is a function to extract the histograms. Now, OpenCV has a bunch of very super useful functions. We don't need to go over pixel by pixel to extract the histograms, but here is what we are doing that using OpenCV functionality. And this is our root folder. Okay, so for each image, we will be constructing features, which is this vector of size 256 multiplied by 3, and we get the label from the name of the folder. Okay, so we are simply going over all the images. We are calling the histogram function, and from the folder name, we get the labels. Okay, so at the end of it, we have total some 2200 plus images, and we have 768, which is 256 multiplied by 3. That's the number of features. Okay, so just like every document is transformed into a vector of fixed size, irrespective of the size of the image, we have transformed it into a vector of dimension 768. All right, so we just split the data, train a logistic regression model, and we make the predictions on test data. And here we have the classification report. If you look, all these are around 0.7-ish. Okay, and if you look at the confusion matrix, this is how it looks like. So in the test data set, we have roughly around 150 images for each of the flower type, and the model is able to predict about 100 to 110, 70% of them accurately. And here we have the confused ones. Now, this is not a great model, but again, the idea is to not to train a best model, but to apply the concepts from one area in another area. Now, the reason why the performance is low, that's because it's not just the color which determine what it is, right? For example, so here we have all these rose flowers. It's not the color, right? So we have the shape, the curve, the variation, the spatial gradients, etc., right? All those make up of what an image is when put together. Now, in this bag of colors concept, we miss all of it. Similar to in bag of words, we are just counting the number of words. We have lost the context, the sequence of the words, which actually make up the meaning, right? So similarly, we lost all the spatial information. We took only the intensity of the colors, but still we are able to do a decent job because this is a very easy job. All three flowers, they have a very distinct color. Okay. As I said, the idea is to apply a concept from one area in another area. I hope you find that interesting. If you find it useful, please consider supporting and sharing in your network. Thank you very much.